Okay, today the topic we are going to discuss is bias and confounding in epidemiological research. It's a very heavy topic, but also very interesting if you know what they are. So we're gonna, um, figure out what those are today. And I have a very, very special guest for today. Laura Koch is a master's student in the School of Kinesiology and Health Studies here at Queen's University. And Laura was actually a student in my class, Health 323, just last year. So very special for me to have Laura today. And I'm sure it's very special for the students who are in the class right now. So yeah, welcome Laura to our podcast. And do you want to introduce yourself to our students?
Sure, yeah. So, like you said, I'm in my master's in the SKHS, and I was in your course last year. So, it's pretty exciting to be back on here and hopefully talk a little bit about what I learned and how what I learned has impacted my research experience in the school. So, I'm doing a master's in health promotion with Dr. Jennifer Tomasone in the Revved Up lab. So, what Revved Up is a community based exercise program for persons with disabilities. So I'm really passionate about breaking down barriers for persons with disabilities to participate in exercise. And specifically, I'm looking at improving quality participation for persons with disabilities in exercise and seeing what we can do in our program to improve the quality and make sure that people have a really great experience in Revved Up.
Nice, very important topic. So can you tell me why you got into that topic, looking at, sports quality and quantity of sports participation among people with disabilities?
Yeah, so like many of the students who might be listening, I was involved in volunteering at Revved Up throughout my undergrad. So it's something that I actually started in first year, and I absolutely loved it. I got to spend 2 hours a week working with participants with varying disabilities, helping them through their exercise program, getting to know them. And it was probably the best experience in my undergrad just because I learned so much and worked on my communication skills and got to meet so many people. And it was just a really great experience. So then I enrolled in the mini stream, which is now the disability and physical activity certificate in the school. So then in third year, I got to do an internship where my actual course was volunteering and Revved Up. So then I got to get a course credit for what I love to do. And I learned more about exercise prescription and how we can tailor the exercise to differing disabilities and abilities. And then in fourth year, I was able to be a supervisor of the program. So I got to learn a bit more about like the programming side of community-based exercise programs. So doing some admin work and also diving deeper into exercise prescription and getting to do reassessments for participants and making sure that their programs are challenging enough to meet their exercise goals. So then I was super interested in learning more about the research side of this because Revved Up serves as both like a practical community program as well as a research lab. So I went in and talked to the professor, Dr. Tomasone, who I took disability with in third year. And I got enrolled in a fourth year thesis and loved it. And here I am now continuing to work with her and doing my master's. So that's the really cool thing about the School of Kinesiology and Health Studies at Queen's is that you get to know your professors really well because the classes are quite small. So then you can feel comfortable going to talk to them about their research. And yeah, it's a really great place to be. And it's been really nice to continue my passion and get to work on it from a research side.
Yeah, nice. Yeah, it's a true privilege for us to have a facility like Revved Up because not many universities have that kind of facilities for researchers that really connect research and community. So yeah, it's really awesome program. And who doesn't want to work with Dr. Tomasone? She's awesome.
Yeah, she's amazing.
Yeah.
I'm so lucky.
Yeah, well, that's really good. So yeah, so today we're gonna now move on to the main topic. So we're gonna talk about biases and confounding that exist in epidemiology, and why it is important to know what they are to understand epidemiological research. So, I highlight to my students all the time that none of the studies are perfect. None of the studies are perfect, but we try to minimize errors that we have or that we may have, right? So before we get into the specifics, so bias is about reducing the error and making your study as much as accurate as possible. So then we can talk about validity first. So there are two types, internal validity and external validity. So can you tell us what they are and how to differentiate those two concepts?
Yeah, for sure. So the nice thing about all these concepts is that the name really helps you remember what they are. So they often give it away in the name. So internal validity is looking at validity within the context of a study. So within a tightly controlled study, when you have a certain target population, you're looking at whether the result that you have is actually accurate for that population. So often we look at internal validity for like randomized control trials in order to make sure that, for example, the COVID vaccine works in the first couple stages of the vaccine trials and it prevents the individuals from getting the disease. And then external validity is looking at more generalized outside the study itself. So whether once you apply the vaccine or the treatment to a larger population, whether it's still going to work in those not so controlled conditions.
I see. So I guess external validity is about generalizability outside of the study sample that you had, whereas internal validity is about, what's going on inside of your study, like within your study, what kind of errors exist. Is that correct? Yeah.
Yeah, absolutely.
Awesome.
And I think it's helpful to think about the different stages that you might do your research in. So often we look for internal validity first to make sure that the drug or the treatment does what we want it to do. And then after that, we want to see if it can be generalized outside of
I
the
see. I see. So when we talk about biases and confounding, then where those fit in between internal and external?
Yeah, so a lot of the controlling that we do within, say, a randomized control trial is to reduce like information bias and selection bias, and that will help us make sure that we have internal validity.
Yeah. Okay. Yeah, that's good. Hold on a second. Okay, that's awesome. So now we know what internal validity is and external validity is. So internal validity is about within the study, errors that exist within the study design, whereas external validity is about generalizability. So is our study finding applicable to a different population? Okay, so that's awesome. So now let's get into biases. So what is bias? I mean, we have our own bias, our personal biases, but what is bias in research?
So bias is anything that's going to impact the results of the study and make it different from the true result.
I see. So we were hoping to get the true result, but we end up not getting the true result.
Yeah, exactly. And it's kind of tricky because we can never really know the true result. We're never going to have a perfect study and there's always going to be bias, but hopefully by reducing some of these biases that we're going to talk about, we can get closer to the truth.
Right. So it's really important point that you just made. So what we can do as a researcher is try to identify what kind of biases that exist and also try to reduce them.
Yeah, absolutely. And also being really transparent in our reporting about the type of biases that might have come up in our study, just so that people reading can understand how the results might be impacted.
Right. So that's why in academic articles, we always have to have a section dedicated to explaining limitations of our study. So that's another important point for sure. So in biases, we have two main types. So that's selection bias and information bias. So let's talk about selection bias first.
Okay.
So what is selection bias?
So in general, when we think of epidemiological studies, we're going to have participants divided into different groups, right? And generally, selection bias speaks to differences that come from the groups because of the selection processes.
Oh, I see. So in epidemiology, we always want to see what kind of risk factor is associated with the outcome, and usually the outcome is health or disease. So we are always divide our sample into two groups. So the selection of our group 1 and group 2 is really important, and also if we do RCT, then selection of treatment group and control group is really important. Same for case control. And we're going to be talking about it in more detail about case control. But yeah, selection bias, it's about selecting samples for epidemiological study, like Laura just described. So let's get into control selection bias. What's that bias specifically?
So when we look at control selection bias, it means that the subjects in the control condition compared to, say, the case condition are already different at baseline. So we haven't randomly sampled our population well enough so that our two groups are equal to start with.
Right. So when you say they're different, like of course it's control and case. So control group shouldn't have the condition and case should have the condition. But what else, what kind of variables that we should match between those two groups?
Right. Yeah. So things like age and sex and BMI, anything that's going to affect someone's health or affect whatever outcome we're looking at, we want to make sure that they're matched between the case and the control groups, or else we're going to start with a biased sample.
Right. So let's say with, I guess, COVID-19, we have COVID-19 cases and non-COVID-19 cases. And if we select different age groups, for example, like let's say we have more younger people in the case, so those who have COVID, and for control we have older age group, then of course we're going to have different, I guess, results because of different age, because the prevalence or incidence of COVID-19 is way higher among young people because they're more mobile. Is that the correct? Yeah, that's good. Okay, so that's control selection bias. The next one is self-selection bias. What's self-selection bias?
So self-selection bias is actually one that's really relevant to my own research because it has to do with the individuals who choose to enroll in the study. So, for example, in my research, I look at individuals enrolled in an exercise program, and I try to look for differences depending on, the quality of their participation. But the people in this exercise program are probably already more motivated to engage in exercise than the general population. So it's difficult for me to make assumptions about this group when they're already different than the general population.
Right. So they already like physical activity, or they already present higher levels of physical activity than the general population with disabilities, for example. Yeah. So then you're gonna have groups of people who like to exercise, and maybe the benefit is better, or they're gonna rate the quality of the program higher because they like it. So how can you control for those? Or do you need to control for those?
So that's something that's really challenging in my research because Revved Up is a great program, and all of my data shows that everyone's having a really great high quality experience, which is good from a practical sense.
Right.
But it's difficult to run my analyses on it because I don't have many people who don't like the program.
Right. So in terms of like age and sex distribution, do you have like good this good representation from each group, or from varying age groups, or what are the characteristics of age and sex of your sample?
Yeah, I would say that generally our sample skews towards an older population just because older individuals are more likely to have disability. Um, and we have a pretty good split of gender in our sample as well.
I see. So, okay. So that's good. At least you have, proportionate gender or sex distribution. So that's good. Okay, so we covered the control selection bias and self-selection bias. The last one that we want to cover is loss to follow-up bias. So what's that?
So this is when we have participants who, after a period of time, aren't responding to the follow-up survey or coming to the follow-up appointment, and it's different between the two groups. So perhaps the participants in the control condition aren't coming back to the appointment to answer the follow-up survey.
I see. So I guess it's more relevant to study designs that have follow-up period or multiple measurement points. So it's not relevant to cross-sectional study, but maybe for cohort study design or RCTs, etc. So then, let's say a study is looking at the associations between physical activity and health. Let's say physical activity and cardiovascular disease, right? And we have physically active individuals and we have physically inactive individuals, and we follow them up for 2 years. And for those who are inactive, we lost, let's say, 30%. And those who are active in the active group, we lost 10%. So then what kind of impact do they have on the result that we're going to have, you think?
Right. So if you lose more participants from the control condition,
or was it control?
I guess from the condition.
Yes. Yeah. Yeah. Physically inactive.
So then you have a higher proportion of people who are physically active. Then perhaps you're going to see a greater impact of physical activity in this study because you have more people returning who are physically active.
Oh, I see. Yeah, because we have now unbalanced sample between the two groups and we have more active people. So maybe the result will bias towards, favoring physical activity. I see. Yeah.
That's what's interesting about this particular bias is that it could bias the results in either direction, depending on which group is less likely to respond to follow-up.
Right. Okay. So if we end up having more physically inactive individuals, then the results will bias towards not favoring physical activity. So physical activity is not as good for cardiovascular disease, as much as we thought it would be. I see. Okay, that's a really good example. Next, let's talk about now information bias. So we talked about selection bias. So now it's information bias. So I guess it's the bias about information that we get. But can you give us a definition of it?
Absolutely. So information bias, we can also think of as measurement bias. So it's any sort of bias in the tools that we're using or the way that we're asking the questions that's going to impact our results.
I see. So it's about measurement, like measuring the variables that we are looking at. And we're going to focus on discussing 3 types. So the first one is biased objective measure. Second one, we call bias. Third one, interviewer bias. So let's start from the top. So biased objective measure, what does that mean?
Right. So when we think of an objective measure, we think that it's a tool that gives us the truth and is measuring whatever variable we have in an objective, non-biased way.
Mm-hmm.
But when we have different types of objective measures, sometimes they have more or less accuracy. So I think the example that you would have given in class last year is an accelerometer versus a pedometer as two ways of measuring physical activity. So they're both considered objective measures, but they work differently and might produce different results.
Right. So because pedometer just give you a number of steps, whereas accelerometer will give you like the intensity steps. It's like Apple Watch or Fitbit that people, or Garmin that people might have. It'll give researchers way more rich information. So I guess pedometer in that sense, even though it's objective, it's limited. And yeah, and also, blood pressure measuring cups. So compared to the home-based one and the one that you can use, for example, from shoppers or the, clinics, it could like the result may be different, right? Yeah. Okay. So yeah.
I was just going to say one example of this in my daily life is that I have a running app on my phone. And when I run outside, it uses a GPS. And when I run inside, it uses an accelerometer. And I get really frustrated when I'm running on the treadmill because it doesn't think I'm going as fast because it's the highest objective measure.
Right. Yeah. Like, and also like I use Apple Watch, and I think though, like it always overestimate the kilos that I run, but it underestimate the calories burned, which is really frustrating. I feel like I really burned my energy and it's not. So yeah, maybe I should learn harder. Yeah. Okay, so that's biased objective measure. So the next one, recall bias, and I'm sure we can relate to this bias even as survey respondents. So can you tell us what it is and maybe example of it too?
Yeah, so again, this is a bias that's really common in the research that I do on physical activity, because when people are answering surveys about physical activity, they know that it's good for them and they know that they should be doing more. And most people tend to overestimate the amount of physical activity they're engaging in. Whereas if I'm going to run a survey on drinking behaviors, I might not admit to as many glasses of wine that I'm really.
Right. So yeah, definitely. So physical activity, definitely there's social desirability bias, which is the part of recall bias. And also drinking too, like after drinking, how many glasses, like how do you remember how many glasses you had last night, right? So, and it doesn't mean that the survey happens the next day, right? It could be like, a month later, like you have to remember your drinking behavior. So recall bias is also really common. But also, recall bias, it's common for really important critical health research. So we covered this one in our earlier course. But with AIDS and HIV research, the difficulty that they faced in early 2000 and 1990s was that people would not report their sexual behaviors and their substance use. So it was really difficult to find causes for HIV and AIDS. So yeah, in critical health research, in all research, recall bias is really important to control, but also in critical health research, it is really important that we recognize and we try to address recall bias as much as we can. Okay, so next one, interviewer bias. What's this one? It sounds like it's the bias coming from interviewer.
Yeah, again, the term kind of gives it away. So this comes from the interviewer perhaps asking leading questions or knowing the characteristics of the participant. So if your study isn't blinded and the interviewer knows something about the participant and might alter their results.
Right. So, we always train interviewers to make sure that they don't have any leading questions, but also like they are oftentimes asked to build rapport with their interviewees. So this is a really tricky one, I think. And in epidemiology, we have exposure and outcome. And if interviewer knows about participants' characteristics in relation to those two conditions, then their own biases may get in the way, right? So for example, HIV and AIDS research, if interviewer know their condition, then they may lead the question like what kind of substance are you using? Are you sure you're not using any of those, etc. Right? So yeah, really relevant to critical health research as well. And we're going to be talking about this later in our course, but in RCT, we talk about blinding, double blinding. So double blinding is blinding participants as well as researchers. So those are the things that we can reduce this type of bias. Okay, so now I kind of gave everyone a hint, but now we're going to talk about how the ways that we can minimize information bias. So for example, with the use of objective measures, so to reduce biased objective measure, what kind of steps or strategies that we can use to reduce this type of bias? Do you have any idea, Laura?
So I guess when you're picking a measure, you want to look in the literature and pick something that has evidence to show that it's valid and reliable.
Right.
You're actually choosing how you're going to measure the different variables.
Right. So I guess, for example, if you want to measure physical activity in research setting, we don't really use Apple Watch because we know that it's not the most accurate one. But we would use, scientific, it's called the triaxial accelerometer, actigraph or actical. Canadian census uses actical. So I guess those are the things that we need to know as a researcher. That's a really great point. What else can we do to minimize information bias? So we talked about biased objective measure. How about recall bias? Is there any way that we can minimize that?
So I have heard of some strategies where instead of taking a survey, a month later after the behavior, sometimes we have apps or ways that you can ask the participant on a daily basis or right after the behavior occurs. So I think that people have a better memory sooner after they engage in a behavior.
Right. So instead of asking someone, okay, a month before, what did you do? You'll be asking, okay, for the past 7 days, what was your behavior look like that, I guess.
Right. And I think on the other hand, when it comes to critical health behaviors, a lot of minimizing recall bias comes in creating a safe space and a welcoming space for people to feel comfortable disclosing their behaviors.
Right. So having some kind of introductory wording or preamble to create that space for participants or for respondents is, I guess, really important. So when you conduct a survey with people with disability, do you usually do in person at the gym?
So before COVID, yes, we would use iPads and we would just ask the volunteer who was working with them to hand them the iPad after their workout, and we would be able to answer any questions they have about the survey.
Right. So that helped for clarification if the wording was too kind of confusing for participants, etc. But obviously we cannot do that anymore. So it's very unfortunate. But yeah, okay. So that's, I guess, another way that we can kind of minimize information bias by providing clarification, but also creating a safe space in the space where they're exercising and interacting with staff there. Yeah. Okay, so we covered biases. Now let's move on to confounding. So these are all kind of complex concepts that we cover in this course. So let's talk about confounding briefly. Like what's confounding?
Right. So I think the easiest way to remember what a confounder is that it's a secondary variable that's causing the change that you see between the exposure and the outcome. And it's really important to measure these so that you are able to control for them.
Right. So it confounds the association that we are interested in looking at, you're saying. So
Mhm.
that's why it's important to control for those and identifying for those. So can you give us some example, like in epidemiological research, what kind of confounders do we have?
Right. So the example that I think about sometimes is there's all these studies that associate the consumption of red meat with heart disease.
Mm-hmm.
And I definitely think there's lots of validity to that. But you have to take a look at the study and see whether they measured smoking behavior. Did they look at BMI? Did they um, look for sex and age? Because a
Mm,
lot of these variables could be related to both the red meat consumption and heart disease and could be
mm-hmm.
producing this effect.
Right. So, just I'm not sure if there's any research and I don't actually know the numbers, but men, let's say men compared to female, compared to women, they're more likely to consume meat, red meat, and also they are more likely. It's proven actually. There's epidemiological data suggesting that heart disease is higher in men compared to women. So, when we talk about probability, of course, there are more men who's eating red meat and there are more men who has heart disease compared to women. So of course we're gonna see that association. So
Mhm.
yeah, I guess sex is a really, really good example of that confounding. Okay, so there are three criteria that must be met to be considered as confounder. So can you explain that a bit?
Right. So the three criteria that a variable must meet to be considered a confounder is that it
Hmm.
has to be associated with the exposure. So in this
Okay.
case, um, men have to eat more red meat.
Hmm.
And then it has to be associated with the outcome. So we
Hmm.
know that men are more likely to get heart disease.
Right.
And it also can't be an intermediate on the causal pathway, which is
It's,
probably the most confusing criteria listed
hmm.
here. So can you explain a little bit more about this causal pathway?
Sure. So, okay, so we can say that, okay, sex is associated with the exposure condition. Sex is definitely associated with red meat consumption because men eat more red meat compared to women, based on our assumption. And also, men is more likely to develop heart disease compared to women. So, sex is associated with the exposure and the outcome, but sex is not on the pathway between those two variables. So sex is not explaining the association. So it's not like red meat consumption leads to having someone having certain type of sex, and then that leads to heart disease. So it doesn't make sense, all right? So it's not the variable that explains the associations, but it's just the variable that is associated with the exposure and the outcome separately.
Right. Yeah. So
Yeah.
a variable that might be on that pathway might
Mm-hmm.
be BMI. So perhaps consumption of more red meat makes
Mm-hmm.
people gain more weight, and then that might lead to heart disease.
Right, right. So BMI or some type of adiposity measure could be in between explaining the association, but not necessarily confounding variable, such as sex, right? Okay, okay, so that's pretty clear. So let's move on to the next one. So we have the oldest confounders, and in every study, when we look at exposure and outcome, because with chronic diseases, we don't have just one cause. For COVID-19 now, at this point, we don't have one cause. The first case, there was only one cause. It was the bat that carried the virus, but now it's whole other things that get in the way. It's like not wearing a mask could be an exposure, could be a cause, right? Um, so given that we have multiple confounders in every study, in every epidemiological study that we are conducting, what type of things that we can do to control for potential confounders?
Yeah, this is challenging, and I think probably one of the most difficult
Mm.
things to do to make sure that your results are unbiased.
Mm-hmm.
So the first thing is, before you design the study and before you collect your measurements, having an
Mm-hmm.
idea of what possible variables could be confounders and making
Mm.
sure you measure all of those things so that you can put it into your stats and control for.
Right. I see. So it's really important that before even we collect data, it is important that we design our study to collect all those potential confounders, so that we have that information and we can enter that information in our statistical analysis, and include them as covariates.
Yeah.
Nice. Yeah. And we can also talk about from the case control study point of view specifically. So, we have case and we have control, and we were talking about, control selection bias. But from this point of view, so to control for confounders, is there anything that we can do when we select our cases and controls?
So when we're selecting our cases and controls, we want to
Mhm.
make sure that they're matched on all the levels of the confounders. So we have,
Right.
if we think that sex and age are might confound our results, then
Mm-hmm.
we want to make sure we have equal proportions of sex in both groups and around the same proportions of all the ages.
I see. I see. So if we think as a researcher, like sex and age, they're the important confounders, then it is important that we make sure we have the same group in terms of age and sex.
Mm-hmm.
I see. So basically creating comparable groups for case and control.
Yeah, exactly.
I see. Okay, so let's move on to the next one. So issues related to confounding. So I think we've talked about this a little bit. But what kind of issues do we have if we fail to control confounders?
So two major issues can be found here.
Mm-hmm.
Either we find a result that's more significant than we expected,
Mm-hmm.
or we fail to detect a result at all.
Right. So if we don't end up controlling for potential confounders, the results may not be reliable. We
Mm-hmm.
may see the results that we are not supposed to have, and that's dangerous from the public health practice point of view because we may, epidemiological research may provide inaccurate information because we fail to control for confounders.
Mm-hmm. Yeah.
Yeah, yeah, okay. That's really important point about confounders for sure. So we talked about minimizing biases, so controlling for biases. But is there anything that you think we forgot, or the important concepts that we need to mention?
I think we have mentioned all the major types of bias. I
Mm-hmm.
guess I just want to really highlight how important these topics are, especially now when there's so much science in the media because of the pandemic we're living through. So I think it's so important for students, whether or not they're going to be doing research and they're going to be using these concepts, to just have an idea of them so that they can critically evaluate the science they're reading in the news.
Yes, that really that connects nicely to our next topic because we're going to be talking about critically appraising epidemiological research articles. So, like I said at the beginning, none of the epidemiological research is perfect, and sometimes there are papers that are invalid and unreliable. But if you don't have critical thinking necessarily, then you may just take the information at a face value, and they could be risky. It's basically it could be pseudoscience that you end up taking information from. So yeah, really important point.
Mm-hmm.
Yeah, okay. Well, I think we covered all the important concepts today. Is there anything that you want to say to our students as a senior member?
I guess I just want to wish them luck on
Hmm.
this online semester. I can't imagine what it's like to, you know, have to go through school online and not be able to see your classmates and your professors. And I just want to let them know that, all the professors in the SKHS are so nice and approachable. And if you're struggling, just let them know and ask for help.
Hmm. Hmm. That's awesome. Well, thanks for coming in, Laura, today, and it was really exciting to talk to you.
Yeah, thanks for having me. It was a good little test of my epidemiology knowledge.
Nice. All right. Thanks, everyone.